let's try this. So another bearings problem. We're looking at number 24 on page 82 of your trig textbook. This one says, flying distance. The bearing from A to C is north 64 degrees west. The bearing from A to B is south 82 degrees west. The bearing from B to C is north 26 degrees east. A plane flying at 350 miles per hour takes 1.8 hours to go from A to B. Find the distance from B to C. So we're going to start off with A to C, north 64 west. Okay, so I put my point A wherever I'd like to have it. Remember that when you're doing bearings using method 2, we start with a north-south line. It says the bearing from A to C is north 64 degrees in the west direction. So make sure from the north line you want to go west 64. So hopefully you went this way, right? And if I just remind myself that that's 90, so 45 would be about halfway. I want to be past that. So I'll put my point C about there. And again, I'm going to move my A so it's not in the way. So it's this angle right here that I know is 64 degrees. Right? It's 64 degrees off the north line in the west direction. All right? The bearing from A to B is south 82 degrees west. So from A, I'm going to go south, and I want to go 82 degrees in the west direction. So that's going to be quite far over. And let me just see, from B to C is going to be north 26 east. So I want B to be a little bit over, yeah, about there maybe. I'll put B. So it's this angle right here that I just figured out was 82 degrees. 82 degrees off the south line in the west direction to get from A to B. And now from B to C, so if I draw myself another north-south line through B, off the north line 26 degrees in the east direction, so this angle will be 26. Does that make sense so far? So there's my rough sketch so far. Then they give me a little bit more information. Let me put this screen down. It's easier to see. Is that better?
You could find that. No, I didn't. That equals 180. Yeah. 180.
So, well, they do give me one other bit of information. Plane flying at 350 miles per hour takes 1.8 hours to go from A to B. So, 350, what is it? 630 miles is A to B. 630 miles. And I am trying to find B to C. So I'm looking for this side. So yes, it will be helpful if I can determine if I have a 90-degree angle and where it would be.
Does it really matter that much on this problem particularly?
430.
Yeah, because without it being a right triangle, you can't do Pythagorean theorem. You can't. But where's the right angle?
Well, it's definitely not that one.
Well, it's not this one, because this one's 34.
That's the one that we need, because we got the X and the 360.
But how do I know? This could be 90 or this could be 90. I'm pretty sure it's this one, because it, but I don't know. You can't go off of looks, right? Just because that one looks like the 90-degree angle doesn't mean that it is.
If you get it right.
Then you're pretty lucky, but you, I mean, it's not that hard to verify that I do have it, hopefully. Well, let's see. If this is, yeah, guys, you can do it the same way that we did in the last problem. Check it out. Are you watching? Watch. You have two parallel lines here. These two dotted lines are both north-south lines, right? So they're parallel to each other. If this is 82, isn't this 82? Because they're alternate interiors? You follow me?
I couldn't get that. I couldn't piece that.
If that's 82, that's 82, which means I know. And if that's 26, then 82 minus 26 tells me that this angle is 56. And now I can confirm, yep, those two are complementary, so this one's got to be 90.
I just guessed it was a right triangle and you're 56.
Me too.
There's no need to guess, though.
I just took a shot.
Ah.
Still got it. Yeah, I think we still got it too.
So now I should be able to, I can kind of ignore all this noise that's on this problem and just look at, there's a 90, this is a 34, this is a 630, and I'm looking for that side. Oh, sorry. I just drew the same triangle but without all the extra stuff that I don't need. So now I can, how'd I get what? They told me it was 350 miles per hour for 1.8 hours. So now I'm going to use what ratio?
Tangent.
What?
No, sine.
I'd use sine. Sine of 34 equals opposite over hypotenuse. And we should be good to go.
I don't get it. I
Yeah,
don't get why you use sine is not opposite.
yeah, I
over.
thought you flipped it because that's A to C.
Isn't this the hypotenuse though?
Yeah,
Yeah,
but in this case, the adjacent side
is
is.
B to A.
Isn't the hypotenuse always adjacent to one of the angles though too? Let me draw it like you normally look at it.
Who's gonna make that argument before?
We have. Well, you're right. You guys haven't, but you've forgotten why I told you. If I'm talking about this angle, aren't both of these sides, X and Y, aren't they both adjacent? However, if you recall me telling you, because that one is across from the 90, it's always the hypotenuse. Hypotenuse trumps being adjacent. So if it's the hypotenuse, it's always the hypotenuse. The hypotenuse will never count as the adjacent side. Ever. Because it's the hypotenuse. It has to be one of the two legs. So the legs are your opposite and your adjacent. Does that make sense?
Yeah.
Okay. So, that's why over here, this 630 has to be the hypotenuse. So, opposite hypotenuse, there it is. And then when I do the calculation, I get sine 34 times 630. I'm here. And if I look back at my problem, I have two significant digits, so my best answer would be 350. Is that all right? Okay.